Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. All right, everyone. I am here at KubeCon in San Diego, and I'm with Bob Killen. Bob is a research cloud administrator at the University of Michigan. Bob, welcome to the TWIML AI podcast.
Thank you.
Awesome. So we met yesterday. You were on the AI ML media and analyst panel, talking a little bit about your experiences using Kubernetes to support the researchers there at the University of Michigan. And you're also, one of the other roles you play is you're a co-chair of the CNCF's research user group. So really interested in hearing a little bit about your experiences with, sounds like you work with Kubernetes kind of to support a broad portfolio of applications, not just ML and AI. Is that right?
We run a wide variety of applications, both AI and ML focused like Cubeflow, but we have a whole slew of other supporting services that our researchers consume generally on our larger HPC cluster.
Tell us a little bit about your background. How did you get started working with Kubernetes?
I moved over to ArcTS, my group, Advanced Research Computing and Technology Services, about 3 years ago. But before that, I worked for the University of Michigan Hospital. And in 2015, we started, going down the container route for a lot of our clinical workflows. This is sort of before Docker was a thing. So we were predominantly like LXC containers. And we were first looking at Kubernetes to orchestrate that, but Kubernetes wasn't mature enough at the time, and we went for Mesos. From there, we then shifted back and forth and also started supporting our research workloads sort of alongside our clinical workflows on there. They sort of saw, some of the benefits of containerization and just wanted to take advantage of the broader service that we were offering. From there, I was hired by ArcTS to sort of build out the same thing, but be completely research focused, as well as like managing a virtualization system. And Kubernetes has really exploded when it comes to the broader management and adoption of containers. And, we have things like the KubeSpanner in Jupyter Hub that just integrates directly with it. Mm-hmm. And from there, it's just...
You said the KubeSpanner?
KubeSpanner, I'm sorry.
KubeSpanner in Jupyter.
In Jupyter Hub.
Yeah. Got it.
So I can spin up a notebook as a container itself.
Can you maybe talk a little bit about the various use cases that you're supporting? What are some of your researchers doing?
Oh, man, it's a pretty broad spectrum. On top of Kubernetes, we support a bunch of social science stuff, various databases that are consumed by other applications and people running workloads in our larger HPC cluster. And we do support, we have a significantly large Jupyter environment, a lot for classes and other researchers that are spinning stuff up. Bioinformatics, physics, I think those are most of the big ones.
Okay, and so is the primary user experience among your researchers the Jupyter Notebook and the ability to spawn off containers from the notebook environment?
Yep. Over time, we've seen a gradual shift of people, sort of the moving away from the classic HPC style system where you would log into there'd be a SSH and a login node, and you'd run your system, or you'd queue something up and run it off. Now there's sort of an expectation to have the Jupyter Notebook or to have some other sort of science gateway for the user to consume. It's a lot friendlier than having to dig in and write like a batch script to automate some of the stuff for you.
One of the things that's different between kind of the classical HPC scale-up systems and the more distributed environments that we see now and that are common with Kubernetes is that in order to take advantage of these distributed environments, the users, and in your case, the researchers, have to know about them and kind of know how to use them in a lot of cases, write their code to take advantage of distributed computing. Are your researchers, doing that, or are there, things that you've put in place that provide abstraction so that they don't have to think about that?
We do have some abstractions in play that make it much easier. Argo workflows and things of that nature have simplified things greatly for people. Then, of course, there are some power users that will just want to dive in and do everything themselves. But in general, we have a pretty good suite of tools and libraries to make that easy for them.
The social scientist isn't kind of the target user for a Cubeflow. Yet they're, using Kubernetes, Cubeflow in your case. It sounds like the Argo workflows, are, well, you didn't say that necessarily the social scientists were using the Argo workflows in Cubeflow, but, I'm curious to hear a little bit about how Cubeflow in particular is used in this environment.
Cubeflow itself, we don't have any social science people using Cubeflow. The Cubeflow stuff is mostly used by a small subset of people, and right now, I'd say more in an experimentation stage, but the aspects of it really sort of make, especially like the model lifecycle of things, significantly easier for people. And we sort of see much more people shifting and adopting it going forward.
Maybe talk a little bit about that user experience. Like, what do they have to do to get their apps up and running in the Cubeflow environment?
They don't have to do too much. They can do most of it from the Jupyter notebooks that Cubeflow spins up and manages for them. And then there's, I forget the Argo or the Cubeflow CLI tool, but that allows them to create some workflows pretty easy too. And there's some other things being built that allows for like better like designing building better pipelines and more consumable workflows.
Maybe talking generally, what from your participation in this panel, I got the impression that you're pretty excited about Kubernetes as a platform generally for these types of research workloads. Maybe talk a little bit about, why you're excited about it.
Sure. Kubernetes provides a lot of like proper abstractions for just managing a variety of workloads. And the things that it cannot handle, it offers the extension points to easily extend and augment. So like Kubernetes itself does not have any capability of running a like standard MPI job or a gang scheduled job. But because the extension points are there, it's easy enough to sort of write your own scheduler to handle that. And it's just like a little, one variable changed, then use that scheduler to spin up and manage that workload. And by using Kubernetes itself and this extension mechanism, you gain the accessibility of using everything else that's being developed on top of Kubernetes. Whereas in the past, again, going back to the classic HPC system, there wasn't any of these other, this other tooling and APIs to really do any of this stuff. So now you can do a lot more, such as like eventing and triggering different workflows off different things happening within the system. We're definitely seeing a much more broader adoption of things like data streaming and Flink. And this stuff you couldn't really, do well on a classic HPC system, but it works and fits quite well on top of Kubernetes, and you can integrate it with a whole slew of other things that are being built on top of it.
Are you supporting users that are doing things like building out their own schedulers, or are these things that the broader community is doing and they can just kind of take off the shelf and take advantage of?
Right now, it's mostly from the broader community, and our users can then take that off the shelf. Cubeflow itself has a MPI operator built into it, so that makes it easier for the people consuming Cubeflow to spin up an MPI job. And then there's other things like Volcano, which are trying to offer much more of the classic batch computing things that we'd find in HPC for Kubernetes directly.
Drill down a little bit deeper into that. What is Volcano specifically?
Volcano is a open source project that is trying to be sort of the classic HPC scheduler, workload managers, thinking like Slurm, but built for Kubernetes. So it is offering things like fair share, queues, backfill, as well as offering things like being able to support gang jobs and things of that nature.
So the idea there being that as a research cloud administrator, you've got some pool of resources, you've got some pool of people that want to take advantage of these resources. How do you fairly or consistently give them access to the resources? And so fair share being, one idea there. Gang scheduling is more like I've got these 5 things that need to go at the same time. And
Exactly.
how do I ensure that they're happening in concert with one another?
Yep. And then like if a worker happens to die, you don't want to necessarily kill the entire job. Whereas, if sort of the controller dies, you want to then, kill and requeue the entire job. For us and for sort of the larger sites that are, still primarily on-prem and focused on like bare metal, we have a finite amount of resources. We aren't necessarily bursting up to the cloud. So being able to backfill and set priorities on things is very useful for us, as well as, queues. For us, it is like we want to backfill with, jobs from students. They might be able to run those for free. But if we have a, researcher that's queuing something, we want to, have those take priority and sort of bump off those lower priority jobs.
When we think about in the context of machine learning, some of these jobs like neural network training, deep learning training, they can take many days or weeks, but that's not a new thing in the context of HPC. Are the workloads that you're tending to support also kind of these long running jobs, but not necessarily deep learning training?
Yeah, we support, again, being a group that handles the research needs for the entire university. We have a little bit of everything. And most of our jobs would probably fit into that category, where they, might take, a week to complete or something of that nature. I think our max wall time is 21 days.
Oh, wow. And can you say what that is?
I don't remember off the top of my head, but we've had several that are just like cranking through, terabytes and terabytes of data. And if they have something that just, hits the wall time, it's unfortunate for the researcher, but it will kill it off.
Oh, so this max wall time isn't the biggest job that you've seen. It's the limit that you've set.
Yes. Sorry. If they have something that runs longer than that, we're going to give them the boot.
Yeah. Oh, nice. Or not nice, maybe.
Yeah.
Asked this question yesterday that you disagreed with, or that you disagreed with the premise, and that was that, one of the things that I've noted here in this conference, the conference has gotten huge. I don't think I was at the first one in San Francisco. I may have been, but I was definitely at the second US one in Seattle, and that was 1,500 people, and now it's 12,000.
Yeah.
It is massive. And, the kind of thought that I posited was, that growth is not in machine learning and AI users. It's in like cloud native, I'm building web apps users, right? And those users have very different concerns, potentially, than the ML and AI users. And I kind of pose as a straw man, like, is it possible, or is there, any concern that, that growing kind of user base and momentum, but focused on kind of a different use case, would have negative impacts on the ML and AI users? Like, hey, to do XYZ in Cubeflow, you need feature or API ABC, but that's a super low priority because none of the web app people need it.
Yeah.
And you were like, yeah, no, I'm not worried about that. So yeah, react to that a little bit.
Some of that stuff is there. So there's like still some issues with like NUMA and some of the more...
What's NUMA?
Yeah, it's the essentially mapping of RAM to CPU core.
Okay.
And when you're scheduling a job, you really don't want to like cross NUMA domains. So you generally want to, and there'll be like GPUs and things like that that are also sort of tied to that. So you don't want to have a pod scheduled on like this other core that then has to sort of jump and go through a round to a different like NUMA domain and path to talk to a GPU. And so some of that stuff, those primitives aren't exactly there. But at this point, there's, some pretty strong drivers for that. A lot from Intel, NVIDIA, and those groups to sort of, firm up those lower end components. And then some of the other things, there's like enough sort of extension points where the core of Kubernetes might not be able to, cater that well to AI and machine learning workloads, but an outside developer could, hook into it or replace that component fairly easily, and then enable it for, again, more research workloads.
Mm-hmm. Yeah, basically the whole panel said essentially, yeah, no, there's nothing to look at here, nothing to worry about that. which was a little less than satisfying. But I think the key takeaway was that the belief was that the Kubernetes core is general enough and has enough extension points that the specific use case, the dominance of the web use case, isn't necessarily going to derail its use in other cases. And I think you or someone else mentioned, and even, there's a lot of attention paid to, it's not just the web use case isn't as homogenous as I'm making it sound. There are a bunch of use cases there, and like there's enough diversity in workloads that the core is kind of staying general and extensible. You're shaking your head.
Yep,
Yes.
Yep. Sorry. I probably should be answering.
No. Go ahead.
Yeah. The core, the people behind the core, Google, Borg, going all the way back, definitely built it in mind to be extendable. They knew from the get-go that, lots of things might come and go, and if you sort of really tied it to one, specific design decision, you'd limit yourself in the future because you really wouldn't know, what's going to happen in a couple of years. Mm-hmm. Who knows, co-scheduling or, gang might actually make its way into Kubernetes core. But right now, that's not really a priority. But it's easy enough to extend and add through, the various extension points.
What are the biggest gaps or things missing, as you are trying to support these AI and ML workloads?
The biggest gap from a general adoption standpoint, I would say, is documentation of best practices. There's, some blog posts and things like that out there, but there is no concise guide when it comes to how do we design and build a cluster? What settings should we set for this sort of thing? Mm-hmm. As part of the research user group, we've pulled a whole slew of users and had, we pulled them actually like live the other day during the session, and documentation and just guided best practices was the number one request both times, and by a wide variety of groups. Mm-hmm.
I've heard similar, by the way, and one particular point that was raised was, for the documentation that does exist and the tutorials that do exist, it's all very GCP focused. And so, there's a whole other set of mental exercises and translations you need to do to get it up and running on AWS, for example.
Yeah.
So besides from documentation?
Besides documentation, from, I would say, broader standpoint, it's a lot of those, the things that like Volcano we're trying to add from a base functionality standpoint. So again, things queues, backfill, better pod priority and preemption capabilities, and things like that, at least to support a better multi-tenant, or I would say a multi-workload environment. Mm-hmm.
And what's the state of GPU support in Kubernetes? Is it as flexible as you need it to be to support the kind of environments?
Right now, you can't share GPUs like you can in some other environments. Mm-hmm. So that's a little bit of a problem. I don't know the status of it. I know there's like an open issue on it.
Meaning you may support fractional CPUs or,
Yep.
Cores. You'd like to be able to offer users fractional GPUs.
Correct. And
okay.
there's like on some of the NVIDIA GPUs, you can sort of like carve them up and give like, half of it to a container. Okay. But that flexibility still isn't really firmed up yet.
It sounds like that's something that would have to come through Kubernetes core as opposed to an extension, or?
I think that would be probably through NVIDIA and their driver. I'm not 100% certain.
Okay.
I'd have to go back and look. There's a long issue that's been open, I think, since early 2018, where there's been a lot of discussion on sort of, who should handle this and where should it be done.
Okay.
I can dig it up later too if you
sure.
like.
Yeah, I mean, curious. I'd be curious to kind of read through its evolution. So GPU support. Your role is kind of managing the Kubernetes cluster, kind of independent of these use cases. How many kind of machines, containers, nodes are you dealing with?
Right now we have about 20 different research groups that are using our our clusters. We have 3 separate clusters. One that we sort of use that like has a bunch of our persistent services that we consume, and they provide services to the other clusters. So things like identity management and like a central point for logging. And then we have another cluster that is for our non-restricted data workloads. That's our relatively general use cluster. And I don't remember the stats off the top of my head, but that's about like, honestly, it's actually pretty small, about 14 nodes, and probably 800 gigs of RAM. I don't remember the cores off the top of my head.
Okay.
And then we have our restricted data cluster. We do have, it's a little bit smaller, and we don't let the end users like talk to that one or consume that one directly, but we will spin up and manage workloads for them. Okay. That's mostly for healthcare.
Like HIPAA types of, okay, got it. When you think about the AI ML workloads that your users are asking for, like where do you see things going from a user perspective? What do they want to do relative to where they are now? What are the things that they're asking about? What are the things they're curious about, excited about?
Honestly, it's mostly extending and better integration of like notebooks into the various workflows. Because we also have a classic HPC system, it's very hard to integrate that with the Kubernetes native ecosystem of tools. We've had and sort of been experimenting with a little bit of bridging the two worlds, because our HPC system has like 30,000 cores. And dramatically larger than our Kubernetes environment, but it doesn't have like it sort of does, but it doesn't have like the ease of use that Kubernetes and our front end does. So we've been doing a little bit of like syncing POSIX identities, sort of the Linux UID and GID, and mapping to our parallel shared file system underneath the hood that's consumed by both services. And for our users, that has been sort of like the next big evolution. And I know like some of the like national labs and other larger sites are also having that same issue.
And maybe kind of last question, going back to this, documentation being the biggest gap. Like, how do you think that gets solved in a community like this?
Well, there are several groups that have some internal documentation, and they've sorted out some best practices. And there's been a couple of good blog posts. The OpenAI blog post, I think from about a year ago, regarding like scaling Kubernetes and running AI ML workloads on 2,500 nodes was a really good one on some of the issues that you'd run into, that sort of thing. Yep.
And I did an interview with one of the folks on that team. We'll drop a link in the show notes. Continue.
Cool. And like I've been talking to some of the folks at like CERN. They've teased out a lot of really good best practices. For now, it's mostly been like time and sort of bringing it all concisely together. For now, it'll probably be, scrubbing it of any, related, internal related documentation, and then like dumping into the Git repo. There's a Git repo for the CNCF research user group, and that's sort of, our collection point of all this various stuff. And once it's there, we'll sort of try and, hit it again and make it a bit more concise.
It sounds like a lot of the need is broader than, just research users. It's everything.
Yeah.
Right.
And there's a lot of people that still like don't necessarily how to run Kubernetes well, and definitely heard that a lot here at KubeCon.
Yeah. Yeah. You mentioned CERN. They're kind of noted for using OpenStack for the infrastructure management. Do you use OpenStack?
We do not use OpenStack. Okay. It's a proprietary virtualization product that was donated to the University of Michigan. It's by a local Michigan company.
Cool. Well, Bob, thanks so much for taking a few minutes to chat with us.
Sure.
Thank you.
Thank you.
All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in the interview, visit twimlai.com/shows. For more information on either of our new study group offerings, causal modeling and machine learning, or the IBM Enterprise AI workflow, visit twimlai.com/learn2020. Of course, if you like what you hear on the podcast, be sure to subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.